One second, guys. All right. Hopefully today my tablet doesn't die. I was about to die in the first class. Okay. Okay, so today we're going to look at angle measures of polygons. So basically what we're going to be able to do is we're going to be able to identify the equation for solving for the angle measures of the interiors of it, so interior angles of a polygon, and then the angle measures for the exterior angles of a polygon. So we're going to get two very important equations which will help us solve for the interior and the exterior measures of a polygon. So just a reminder about the angle measures of a triangle. This was asking what is the measure of angle C? Well, as far as triangles go, we already know that triangles, all the interior angles of a triangle equal to 180. And so given that, we're able to solve for our missing angle, angle C, by basically just taking 180 and subtracting it from those angles that we already have. So we have 54 and 85. 54 plus 85 is 139, and so 180 minus 139 is 41. So basically the missing angle, angle C, is equal to 41 degrees. So that's what we know about the interior angles of a triangle. Basically, because we know all the interior angles equal to 180, we can solve that way. But today we're going to get into polygons. Polygons are basically closed figures formed by three or more line segments such that each line segment intersects exactly two other segments, one at each endpoint, and no segments with a common endpoint are collinear. So basically, polygons that we're going to see are basically just shapes formed by different line segments connecting each other. However, we have different types of polygons. We have concave polygons, convex polygons, and n-gons. Convex polygons are basically going to be polygons. This is our convex polygon, where every line segment connects any 2 points on the polygon itself will consist of no points outside the polygon. So basically, all those line segments connect. It connects one point to the next point, one point to the next point, and so on and so forth. Concave polygons, on the other hand, look like this. And concave polygons state that the extensions of at least one side or diagonal contains a point on the inside of the polygon. So concave, you can think as being caved in. So it's caving in. And so basically, one set of line segments or multiple, it just depends, they intersect at points inside the polygon, so on the inside of it. So concave, think is caving in, and that's concave polygons. They look like that. And then we also have what are known as n-gons. N-gons are basically going to be polygons that are represented by the number of sides. So like pentagon, hexagon, all of those polygons are named based on the number of sides that we have. Yeah, so we can have monogon, digon, trigon, pentagon, all these different things. And basically those things are named based on the number of sides that that polygon has. Well, what we're going to learn today is how to solve for the interior angles of polygons and the exterior angles of polygons. So whenever we're solving for the interior angles of polygons, what we're going to use is the polygon interior angle sum theorem. This basically says that the sum of the measure of the interior angles of any n-gon, so any pentagon with so many number of sides where n represents the number of sides, is 180 times n minus 2, where n is the number of sides of polygons. So basically, say that I'm asked to find what is the sum of the measure of the interior angles of a pentagon. Well, pentagons have 5 sides. And I'll share a document with you that tells you basically all the different types of pentagons you can have or polygons you can have and what the name is depending on the number of sides. But penta means 5, so that's a 5-sided polygon. And so basically, because I know that the pentagon has 5 sides, I can use the equation 180 times n minus 2. And I'll substitute n for my number of sides. My number of sides is 5. And by doing this, I'll be able to identify what the sum of all the interior angles of my pentagon is. So 180 times 3, that's 540. So basically, all the angles of my pentagon will equal to 540. So I'll draw something that looks like a pentagon here. Pentagon's kind of going to look like this. It'll have 5 sides. And basically what it's saying is the sum of this angle plus this angle plus this angle plus this angle plus this angle have to equal to 540. Okay? So we use this equation to solve for what is the sum of all the angles inside of a polygon. Okay? So say we have something like this. Here we're asked, what is the measure of angle K? So we're looking for the measure of this. So basically what we're going to do here is the first thing we're going to do is we know that K is an interior angle. Okay? K is an interior angle. So I want to solve what is the sum of all my angles have to be. So there's 1 side, 2 sides, 3 sides, 4 sides, 5 sides, and 6 sides. So this polygon has 6 sides. So I want to solve the sum of my interior angles. So I'm going to use this equation. N is equal to 6. (180 times 4 is 720. So basically, the sum of all my angles has to equal to 720. Well, I know I know the measure of all my angles except for one. So I'm going to do the same thing that I did when I was working with the triangle. Basically, I'm going to take 720 and subtract it from my other angles. So the sum of my other angles. So 106, 115, 154, 90, 107. So I'm subtracting my total sum of my interior angles by the angles that I already know, because I'm only missing one angle. So, and this is equal to 572. So I'm subtracting that, and I'll find that my missing angle measure is 148. Because if this was 148, well then all my angles added together would in fact equal to 720. Okay, any questions here? So basically what we're doing is the same thing as we did with the triangle. Once we know the sum of all those interior angles, we can solve the missing side. All we have to do is subtract our total by what we already have and find the missing. Okay? But in polygon's case, the interior angles, the sum of the interior angles depends on the number of sides. And so that's why we use this equation right here. Okay? So what if I have a regular polygon? Well, remember that regular polygons are equilateral and equiangular. So here we have a regular polygon. Equilateral means all the sides are the same. And equiangular means all the angles are the same. So everything's congruent to each other. Well, what if I wanted to solve for the measure of each of these angles? Well, because they are equiangular, this is a regular polygon, all the angles will be equal to each other. So all the angles have to be equal to each other. So that being said, I can find the sum of the interior angles. So 1, 2, 3, 4, 5, n is 5. Plug that into my equation. That is 540. And if I wanted to solve for the angle or the missing angle measures of all of these sides, well, because it's equiangular, all the angles are the same. Basically, I could take the total distance or the total measure of all the interior angles and divide it by the number of sides, because all the angles will be the same, and that will tell me that each of my angles is equal to, is equal to 108 degrees. So this one's equal to 108, this one's equal to 108, this one's equal to 108, this one. And why is that? Well, because it's a regular polygon, so all the angles are the same. So basically, I can solve for the angle measures of all the angles in a regular polygon, because all I have to do is take the entire interior angle divided by the number of sides, and I solve. Any questions about this? And this only applies for regular polygons. So you'll be told it's a regular polygon or it's equiangular, and then you'll be able to solve that way if it is in fact a regular polygon. If it is not a regular polygon, then you're most likely only going to be solving for one missing angle, and you would do this process. Okay. So what if I'm asked to find the sum of the interior angles of each cell in a honeycomb? Well, honeycomb is created using a hexagon. And a hexagon has 6 sides. So you'll see that this is 1, 2, 3, 4, 5, 6. That means n is equal to 6. So am I able to solve for the sum of the measure of the interior angles of each of those cells in the honeycomb? Well, yes, I am. I'll take 180 minus n minus 2. N is 6. 180 times 4 is 720. And actually, a honeycomb is a regular polygon. So if I wanted to solve for each of the angles, all I would take is 720 divided by 6. That means each angle on the honeycomb is equal to 120 degrees. Okay. So what if can I work backwards? What if I'm asked to identify, it says an internal angle of a regular polygon has a measure of 140 degrees. What type of polygon is it? So what if I'm told that I have a regular polygon whose angles measure to 140 degrees. All the angles measure to 140 degrees. Why? Because a regular polygon is equiangular. Well, based on that, if all my angles of my regular polygon are equal to 140 degrees, how can I determine what type of polygon I have? Well, you can. And the way you do that is you use this equation right here. 180 and n minus 2 over n. This will allow you to work backwards to solve for the number of sides of this regular polygon. So basically, this equation is equal to 140. And so now I'm going to solve for n. 180 minus n. Okay? And I'm just simplifying to solve for n. Let me distribute this. I'm just trying to solve for n, find out what n is, the number of sides. Yes, okay. That gives me so n is equal to 9. So basically using this equation, I'll write it again right here. What I'm able to do is I'm able to, not 180, is solve back to find the number of sides of my regular polygon. And so because this has 9 sides, this would be a nonagon. And again, I'll share a table with you that tells you, depending on the number of sides, you would name it like this. So we would work backwards using this equation to solve for n, the number of sides. Okay. So what about exterior angles? So exterior angles are polygons. An exterior angle of a polygon is an angle formed by a side of the polygon and an extending of an adjacent side. So basically our exterior angles are those angles on the exterior. Okay. How do we solve for the sum of these exterior angles? Well, the sum of the measure of exterior angles of a convex polygon, one at the vertex, is 360. So the exterior angles are always going to be equal to 360. So say here I have a regular polygon or regular pentagon, and I'm asked to find what is the measure of each exterior angle. Well, I have 5 sides, and my exterior angles are equal to 360 degrees. So that being said, I would take 360 and divide it by n, which is 5. So each of those angles is equal to 72 degrees. So that's one way I can solve. The other way I can solve is I can solve for the exterior or the interior angles of this polygon. And then find out what each interior angle is equal to, 108. And if this is equal to 108, the interior angle, and these extending lines form a straight line right there, then what I can do is just take 180 minus 108, and I'd find that that is equal to 72 degrees as well. So I can use this method, method 1, which takes the total sum of my exterior angles and divide it by the number of sides, or I can use method 2, where I find the interior angle of this regular polygon, so all of them will be the same because it's a regular polygon. Regular polygons are equiangular. And then work backwards to solve for my missing exterior angle. So if each of these exterior angles forms a straight line, the exterior and the interior form a straight line, they're equal to 180, so the sum would be 180. So you're just solving for that missing angle, which is 72. 72. Okay. Any questions about this? So what if I have something like this? So what is the unknown measure? Well, this is 90. So I'm looking, what is the measure of this angle right here? What do I know about my exterior angles of my polygons? The exterior angle of all polygons is equal to 360 degrees. So basically I could take 360 and subtract it from those angles that I already know. So 90 plus 72 plus 96 plus 82 minus 340. So 20. So that means that this missing angle has to equal to 20. Okay. Well, what does that mean x is? Well, if that has to equal to 20, then I take x plus 7 equals to 20. Solve for x. X is equal to 13. Okay. So remember that for every polygon, doesn't matter what kind of polygon it is, the exterior angle is going to equal to 360 degrees. Or for any convex polygon, right? The exterior angle measure is going to equal to 360 degrees. And so given that information, you're able to solve for missing angle measures by taking 360, subtracting it from what you have. And you'll be able to see that that missing angle is equal to 20. Okay. Questions, concerns? Okay, so what did we learn today? We learned that polygon interior angles sum theorem. Basically, it says that the sum of the measure of interior angles of n-gons is 180 times n minus 2, where n is the number of sides. So basically, you're going to use this equation whenever you have an n-gon. You're going to use this equation. N will be your number of sides. And what you'll get is a output, which tells you what is the sum of all your interior angles. And so you can use that information to solve for the interior angles of a regular polygon, or you can find the missing angle of just a polygon that's not a regular polygon. And then we learned the polygon exterior angle sum theorem that basically says the measure of all convex polygons, all those angles, all the exterior angles equal together, give you 360 degrees. Okay. Any questions here? No? So today you should be able to solve for the interior angles and the exterior angles of a polygon. Okay? All right. We'll go over some practice problems very soon, but if there's no other questions, you guys may log off, and I will see you guys on Monday. Bye, guys. Have a good weekend. Bye, Joelle.